We are continuing the ionic compound formula video from part 1 to part 2 now. So we're trying to say, how do we make a formula correct when we're trying to make two ions come together? And the key to it is make it neutral. So you ask yourself, if I just put these two ions together, will they make zero charge together? +2 and -3 do not go together to make 0. So which one do I need more of to try to make it neutral? The one that needs to be more is magnesium. Now I'm showing you a process. I'm not showing you the straight answer. I'm trying to help you understand how we get to the answer, or why the answer is what the answer is. Now I've added magnesium. We now have a +4 total charge and a -3 charge with our phosphorus. Now it's still not neutral, and the phosphorus is less than the magnesium, so we add more phosphorus. Try to bring up the low side. Now we have a -6 total of phosphorus charge, and we have +2 and +2, which is +4 total charge on our magnesium. If we add one more magnesium, that will bring up the magnesium's plus charge total to 6. And that will match the -6 of the phosphorus. So with 3 magnesiums and 2 phosphorus, we now have the combination to make a neutral compound. So the formula is Mg3, because it takes 3 pieces of Mg with their +2 charges to make a combination with phosphorus that will make neutral total. And P2. When we look at the next one, we are going to see something called a polyatomic ion, and that is a group, or one of my students said a nice word, a bundle of elements all together that go together to make one ion. They behave as though they are all one atom, but they're not. Obviously, they are a group of atoms, in this case 1 nitrogen and 3 oxygen atoms. But because they are a bundle, we're going to have to treat them slightly different than we treat these up here, and we'll get to that in just a sec. So we have the same question though, is this neutral? If I just put this ion with this ion, will it be neutral? And the answer is no. So I'm going to have an extra piece of this negative charge, and this is nitrate. I'll go ahead and tell you that's nitrate. I'm going to have an extra piece of nitrate with its -1 charge to make the neutral compound with barium. So the final combination is going to be barium 1 time and nitrate 2 times. Now here's the trick. With polyatomic ions, you have to show in your formula that the polyatomic ion, the whole bundle, is what is doubled. And the way they do that is by setting the polyatomic ion inside parentheses. Everything that is the polyatomic ion goes inside the parentheses, and then if you want to show that it had to be doubled or even tripled, then you put that number outside the parentheses after the ion. So this would be the correct formula for barium nitrate. It had to have 2 whole copies of this bundle, nitrate, NO3, matched up with 1 copy of barium to make the neutral compound. And finally, a big fat polyatomic ion compound made up of ammonium ion, which is a polyatomic ion itself, and phosphate ion, which is another polyatomic ion. Now, these are big complicated ions, but they function just like the more simple ones do. So we ask ourselves the same question. Is it neutral if I just smash these two together just like they are? And the answer is no, because +1 and -3 don't go together to make 0. So we're going to need several more copies of +1 ammonium in order to make a neutral combination. So we will need a total of 3 copies of ammonium ion to match up with 1 copy of phosphate ion. These 3 +1 charges matched up with that single -3 charge to make it neutral. Now that we know what pieces need to be in the formula, let's look at what the formula is going to actually look like. So we write the plus part first, but ammonium had to be repeated 3 times. So because it is a bundle that acts like a single thing, we place the polyatomic ion inside parentheses, and then outside the parentheses we write the 3 to represent how many times that entire bundle had to be repeated. Sometimes it's helpful for my students if I refer to this as a Happy Meal. This represents the same thing as a Happy Meal does. When you buy a Happy Meal, you buy one bundle, one package that includes your chicken nuggets and your fries and your drink and your toy. If you say, I want 2 Happy Meals, that means you get 2 copies of everything that a Happy Meal is. If you get 3 Happy Meals, you get 3 copies of everything that a Happy Meal is. So if you have 4 chicken nuggets in your Happy Meal and you buy 3 Happy Meals, that means you're going to come up with a total of 12 chicken nuggets, etc., etc. So I only have to have 1 copy of phosphate, so I'm just going to write it just like it is in its plain state. Phosphate does not need parentheses around it because it's only 1 time in the formula, and since it doesn't have to be repeated, you don't have to set it apart and with parentheses to repeat it. So you just don't put any parentheses. Ammonium phosphate. Hope this helps.